has come out for tonight. Just to look at what we got going on, we have Matt Isley here with us tonight from Aero. Next week, we have Dr. Berg coming from MAE department to come speak to us about his research, I believe. And then 2 weeks from now, we have Eric Jacuzzi, who is an active AIAA member, coming to talk about his work over at NASCAR, I believe in Mooresville, but good old NASCAR City. Before I introduce Matt, we are selling shirts, stickers, and you can pick those up at EB3. And our link tree is on the side. And I'll put the attendance link here in the chat in just a sec. But Matt Isley is, if I'm pronouncing the last name correctly, is joining us from Oregon. He is a general manager at Aero Air, graduated from NC State with a business administration master's and a bachelor's degree in electrical engineering. So we're lucky to have him here today. So I will stop sharing and hand it over.
Thank you, guys. Good to see everybody. I'm glad the aerospace engineering program at NC State is alive and well. Let's see, I'd like to go ahead and, Josh, if it's all right, I'm going to hit the share screen button here. And I just got a little bit of information to share here with you guys. So I grew up in a little town, a little bit west of Raleigh, about an hour, called Hall River. It's Burlington. So I don't know if we got any Hall River, Burlington, especially Cummings High School graduates. Let me know. Send me a note on here if you are, because that's pretty cool. After high school, I went to the Navy, spent some time on a submarine there. So definitely let me know if there's anybody on this call who's a submarine veteran or a former Navy guy as well, Navy person. After the Navy, I went to North Carolina State. I was a Carolina fan the first, 22 years of my life until I decided I wanted to go be an engineer. It turns out at Chapel Hill, you're kind of out of luck if you want to get an engineering degree. So I don't care what Kiplinger's Personal Finance says about their best value education thing they've got going over there. If you want to be an engineer, it's a terrible value. So ended up at NC State, and of course now, lifelong Wolfpack fan, at least starting at year 22 anyway. So I guess for 28 years I've been a Wolfpack fan. I got my Bachelor of Science in electrical engineering, and one of the things I participated in when I was an undergrad was the co-op program, which was fantastic and gave me a lot of opportunities to understand how to practically apply what I was learning, which actually helped the learning process and actually made it easier to figure out what I wanted to do with my life. After that, I worked for Sony Ericsson as an RF antenna engineer, sort of the dark arts, as people call them. If you know any antenna engineers, and they're not that many, they're pretty weird guys or weird dudes. So, and then you combine that with being on a submarine, and it's a recipe for disaster. So, that was a fun time. That was a good experience. I went back to school at night to get my master's in business because I wanted to, I felt like there were some other things out there I wanted to learn about, and I felt like the clock was ticking for me. I needed to do it now or forever hold my peace. So I completed that in 2003. And while I was doing that, I had the great fortune to be able to work on some interesting projects with some friends here that I met at NC State and a professor there, and did some consulting, and that kind of turned into an opportunity to go work for a company called Firstmark Aerospace, based in Creedmoor. Firstmark was a company. It came out of an old legacy Honeywell business, and they actually manufactured a lot of airframe parts, servos and actuator, fuel probes, flux valves, a lot of old legacy, flight control components. So, while I was there, I was a program manager, started out as a program manager, was involved in the design and certification of the thrust vector actuator motor for the THAAD missile program, which they still make there today. It is a pretty cool product. Then as the company grew and we started becoming more profitable, we looked at acquisitions. And, I want to tell you guys some of this stuff just because I want you to have an idea of what kind of exciting adventure that you're about to embark on, as you graduate from NC State. And really, I can tell you without a doubt that what you're learning there, what you're, not just the detailed material, but just how to think and how to look at things is going to be extremely valuable to you in your career. And being an engineer, it will put you in a unique position to do anything you want, really, as you go forward. So, because of my engineering background, and my ability to look at things and understand them, irrespective of whether it was electrical engineering or not, I was in a unique position with the company to head up our corporate development efforts, which is like mergers and acquisitions. So over the course of 7 years, we did 5 acquisitions. And what I would do is I would go in with a team, understand the business model of whatever business we were looking at, identify the targets, the companies that we thought would be interesting to bring under our portfolio. And then I would come in with the lawyers and the accountants and lead the due diligence efforts. Then we would get a deal done, and many deals don't happen. Many deals you get to the 11th hour and they fall apart, which feels bad, but you got to make tough choices. But we got a few things done, and we were a small business. We bought smaller companies, typically under $10 million a year, revenues, mom and pop type businesses, and then we integrated them into our operations. And so over the course of time, we did this. Eventually, I led the entire organization, which was a company that made aviation safety restraints. You sit in your car, you put your seatbelt on, and no one understands how that might be the most highly regulated part on an airframe, more so than the engine, for God's sakes. It's crazy what the FAA has done with safety restraints, but that created a unique opportunity for us because of the intense regulations, and we had a good position in the market. A company called Centroid, which is manufactures defense electronic components based in Long Island. So I would split my time between New York and Creedmoor. First Mark Controls is a company that builds position transducers for all kinds of different applications, but a lot of aerospace stuff. And then one of the things that's most relevant to what I want to discuss with you guys today is for 10 years, I led a company called Twin Commander Aircraft. And if you're familiar with the Aero commander, Bob Hoover, famous air show pilot, this is what he flew in the air shows and would do his famous engine out routines. And if you are not familiar with that, I would recommend you YouTube Bob Hoover and the Shrike Commander, because what this guy did as a pilot, will never be done again. It's pretty amazing stuff, and he did this in a business aircraft. So, but his history is long, and we could sit here and talk for him, for a couple of days, talk about Bob Hoover. But check that out if you're interested in that. And so that company, in addition to owning the type certificate and being responsible for the airworthiness of a fleet of 1,800 plus aircraft, also maintained part support to keep those aircraft flying. So I would argue, as far as legacy aircraft, which means aircraft that are out of production, probably the best supported aircraft out there that's an out of production aircraft. And in fact, some people would argue it's supported better than some aircraft that are in production. So, and there are many reasons for that, but the engineering side of things definitely had something to do with that. We sold the company off to a private equity group, and it's part now of Ontic, Ontic is a large manufacturer of aviation components out there, and the company's thriving today. So about 3 years ago, I left the company to come work for Aero Air. Aero Air is a business. We are, just primarily an aviation services provider. We have three lines of business: fixed base operation, which is maintenance, hangars, fuel, that kind of stuff. That's a small part of our business. The other part of our business that's interesting is emergency medical transport. So we have about 30 aircraft we have that operate with med beds in them that are used for patient transport. And then we are also in the aerial firefighting business with our Erickson Aero tanker subsidiary. And I'll show you guys a few images here. This is the medevac and transplant side. So what we have is a fleet of, we have 5 Cessna Mustangs. We have a Challenger 601. We have 8 Lears. We have 4 Lear 31s, 4 Lear 35s, and 2 Lear 45s. We have a couple of CJ3s, a CJ4 Citation, and we also have about 6 PC-12s and 6 King Airs that we use for various missions in the medevac space. So a medevac aircraft is an aircraft that is typically just a private aircraft, commercial type aircraft that's modified with a med bed. And so there's a supplemental type certificate for putting one of these med bed systems in, and it gets pretty complex because there's a lot of modifications to the inside of the aircraft. And every aircraft type is mission specific. So we have bases in Anchorage, we have bases in Fairbanks, Alaska, in Juneau, Alaska, in Kodiak, in Dutch Harbor, and each one of those bases sort of needs a specific group of characteristics for the aircraft. You need something with long range for flying from Anchorage to many of the bases we go to. To go into Dutch Harbor, you need something with thrust reversers, that can stop on a dime. And for Fairbanks, you need something that can climb really quick. So, and then of course in Alaska, you're sometimes operating out of unimproved runways, so you may have a gravel kit or something like that. So it's really important when we're speccing out these aircraft to make sure we understand what the capabilities are and what the needs of the customer are there. So let's see, the aerial firefighting business. This is the craziest thing. I tell you, living on the East Coast, you don't really understand what fire season means, but on the West Coast, it's a real thing. California is, basically has a fire season that's 11 and a half months long. We had our air tankers operating this year on contract with the Forest Service in November, December, January, and some into February, which normally the fire season is April to October. We also operate on contract for Minnesota, for Oregon Department of Forestry, and for Cal Fire. So what we did is back about 8 years ago, we bought a fleet of 6 MD-87 aircraft, and these were the old American Airlines, passenger aircraft. We bought these from Spanair. I think there was one that came from Japan Air, and embarked on our own engineering project. And so if you look at these pictures, you'll see down on the left, that's one of our aircraft. That looks like computer generated, but it's really not. It's actually about 3 years ago in Napa, the fires that were going on there. That's an aircraft doing retardant drops there. The retardant is not deployed directly on the fires. It's actually used to lay down a line that's pretty far away from the fire. You sort of box it in, and you have people on the ground that come in and clear areas to keep the wildfires from spreading. There are other types of aircraft for dropping water, helicopters, and that kind of thing. If you look over to the right, if you ever think you're having a stressful day at school, that is an image of the Paradise Fire 2 years ago in California. Our tanker mechanics swapping out an engine. We had an engine issue, And what you see in the background, that red light, that's actually 10:30 in the morning. And that the fires were a couple of miles away. So, you think you've had a stressful day, think about trying to swap out an engine with a fire coming at you. It looks like you're on the surface of the sun there, but I would say that might be one of the most hectic endeavors those guys ever embarked on, because we had to get the tanker out of there. We had to get that engine on. So yeah, things got pretty testy there for a minute. But I love that picture just because you know you don't think about, oh, it looks kind of cool, but it's like, no, that's 10:30 in the morning. That's a fire in the background. So and then this next one is one of my favorites. Think about that when you're at the state fair eating a corn dog this year. That's out in California. That's about 4 or 5 years ago, a fire that was encroaching there on the coast. So, yeah, kind of a cool little picture. So those drops are typically happening about 150 feet off the ground, and most passenger airliners aren't designed to do a whole lot 150 feet off the ground except for land. So that's why we drop with our gear down, because that's how the aircraft was certified. We are in the middle of trying to modify that, and we've got a big project that we're undergoing to do that. But so, this is all kind of cool and everything, but how does it, why does this matter to a bunch of aerospace engineering students? Well, there's a lot of things you can do with your career. If I had it to do all over again, and of course this is something I didn't have a good appreciation for when I was a young man, but uh, in the course of my career, I've been fortunate enough to work with a lot of different folks from the FAA on the engineering side, as well as the manufacturing side. And one of the more interesting groups of people in terms of, me being envious of their career path is what's called DERs. And I don't know if you guys know kind of what a DER is or does. This is something, it's a little more than, getting your professional engineer's license. This is something that you're actually an agent, if you will, of the FAA, a designated engineering representative. And so you're appointed by the FAA, and it's based on several things, your years of experience, your knowledge level. There's a test. You have an advisor within the FAA. And essentially what it is, it's a force multiplier for the FAA, because, all the engineering documents and all the things that need to get approved from all the aviation companies out there. And this is not just companies that build aircraft. This is companies that build parts, companies that, that make windows for aircraft, companies that make engines, propellers, all these kinds of things. There's a lot of engineering data that goes into substantiating these things. And so what the FAA does is they appoint these DERs to sort of be the people that present data and recommend or approve technical data to the FAA. And it helps them sort of get out there and they can do a lot with fewer resources, which has been the trend inside the FAA for a number of years. But I've interfaced with many different types of DERs. There's two basic types, which is a company DER and a consultant DER. And all the consultant DER designation means is you're outside of a company, you're independent or whatever. Companies that have large enough resources, large enough organizations, they need their own internal DERs. And so you kind of work for the company. You definitely work for the company because they're the ones paying you, but you're sort of beholden to the FAA because, you're putting your DER stamp on this technical data and approving it, right? So there are many different types of DERs. You get in the cabin, you got noise levels and things like that. You got acoustical guys, you got guys that do vibration analysis, for engines, for airframes. You definitely have engine and power plant DERs. You have flight test DERs, and even the test pilots that are DERs in some cases. You have the guys that are DERs that specialize in propellers, and you have electrical DERs that deal with the avionics, radio systems, radar, all that kind of stuff. And the one I think is most applicable to standard when I think of aerospace engineering or mechanical engineering is structural DERs, and that's the most common type, because just about anything you do to an aircraft has structural implications, right? And then of course there's systems DERs as well. I'll tell you, when I ran Twin Commander, we had an interesting project. We had to demonstrate that our aircraft was not subject to ice contaminated tail stall. So there was a Colgan Air crash up in Buffalo 12, 13 years ago that happened, and it caused everybody to look at the characteristics of their aircraft. So, the tail of a Twin Commander, the elevator, the ice contaminated tail stall would come into play for just about any aircraft at lower speeds, right? So we were thinking about, how are we going to do this? How are we going to look at the from an engineering standpoint, whether or not, what the characteristics of the aircraft are with ice on the tail at any speed, high or low. One company that had some pretty deep pockets, they flew their aircraft behind a KC-135 that was spitting out, yellow colored fluid, so they could see the ice build up on their wings and on their control surfaces. But they spent several $1 million to do that. We worked with a guy named Leonard Wish, who is an icing DER. The guy he actually has a PhD in icing, which I didn't even know was a thing. It sounds like a Batman character, like Arnold Schwarzenegger, right? Like, what was his name? Dr. Freeze probably has a PhD in icing. I'm just guessing. But what this gentleman did is he had these discrete models, these ice models, to go on control surfaces on the aircraft that were FAA approved. And he was able to simulate a worst case scenario for ice buildup on the tail of the Commander, and then demonstrate that at low speeds, coming in for a landing, whatever, that we still had complete control over the aircraft. So we spent a couple $100,000 in lieu of a couple $1 million to do that analysis, and I think we ended up with a better answer than the company that spent a couple $1 million. So we didn't have to go out and modify anything, but it was one of those things where everybody flying, they'll tell you, that thing flies fine with ice, whatever. But that data is not sufficient. It doesn't hold up to the FAA, right? So, there was an instance where we used a special type of DER. When we were certifying our tanker, and I'll show you some pictures in a minute, we actually, here, I'm gonna show you a couple. Here's a Twin Commander being modified to put a medical bed in, and it actually is undergoing a series of mods. The engineering we had to perform on this was pretty minimal, but the engineering that went into designing those mods had been done, decades before. And so, you really get involved when you start modifying an aircraft to that extent. And there's all kinds of engineering that has to go on. Everything from, hey, there's a rivet hole here. The rivet hole is oversized because it's been drilled out too many times. So I need to put in a doubler, or I need to put another fastener in here. How much edge distance do I need? Guess what? DER is the guy that is the one that has to tell you that, has to substantiate that. So there's all kinds of little things that you wouldn't expect are involved, but it gets pretty involved. It gets pretty heavy on the engineering side. Just real quick, this is our firebomber, our MD-87, and you can see the pod that we put on the front. When we first built this, the retardant came directly out of the fuselage. We had some doors, some special doors and everything. And the air around an aircraft is made as much as possible to flow over the wing. So we actually started getting retardant ingested into our engines. And so, of course, we stopped what we were doing. one place you don't want something that puts out fire is the engine. The only place where you kind of want things burning in there. So we designed this pod, which basically moved the retardant out of the dirty airflow around the hull into clean airspace. It gave us better control of our drop pattern and all kinds of things. But you see the picture on the right with the guy looking at it. That's our pod assembly turned on its side. You can see the chutes to the right where the guy's head is, and then there's actually a series of doors that are down inside that the actuator assembly on the foreground controls. There's a lot of engineering and a lot of fluid flow and dynamics that went into the design of just that pod, but you're hanging a 6,000 pound structure off of the bottom of the aircraft. And in addition, and I'm going to show you some pictures here of what the inside of the aircraft was modified. So we gutted the inside of the aircraft. You're cutting a hole in the bottom. So there's a lot of structural engineering that goes on. It says, where you need to have airframe structural members. We're putting a tank in there that holds 3,000 gallons of retardant that weighs 9 pounds a gallon. So 27,000 pounds of retardant inside of this thing, right? In a concentrated space. So you can just kind of see, the extent of the modifications. If you look over to the left, that picture to the left, there's a guy there in the right-hand side of that picture. If you can zoom in on that guy, he's got an NC State hat on. Now, I'm just going to tell you, that was 8 years ago, that guy. I wasn't even at the company then, so I didn't have any influence. That guy, that's not Photoshopped. That was down in Arizona. I don't even know that guy, but I thought that was appropriate to include that picture today. So there you go. If you look at the picture at the bottom right, you can kind of look up and see the cam sort of shaft that drives the doors opening and shutting. So what we have to be able to do when we're deploying this retardant is we have to be able to open and shut the doors under pressure to deploy a set amount of retardant. And we have to also be able to control the coverage levels. So when we certified this aircraft, we had to do drops over a grid pattern where they actually measured how much retardant hit the ground in certain spots. And again, it just goes back to, there's an old passenger aircraft with all the seats ripped out of it. And we cut a big hole in the bottom of it and mounted this tank inside and mounted a pod on the outside. So, what kind of engineering did we have to do? Well, there was all the structural engineering. There was a lot of electrical engineering that had to go on there. Then when we did flight testing, we had flutter DERs, which are a special kind of flight test DERs. We had DER pilots that rode the airplane and tested the stall characteristics. So one of the reasons we deploy retardant with our gear down is because the pod changed the stall characteristics such that we had to drop with the gear down to kind of dirty up the air a little bit. Like I said, we're working on a project, again, with a lot of DERs involved. We're going to spend about $1 million to certify the aircraft with dropping with the landing gear up. So, the DERs out there are a very important part of the industry. There aren't enough to go around. The FAA, in fact, only has one flutter engineer in all of the FAA because everybody else is retired. And, companies like Boeing, companies like Airbus, companies like Piper and Cessna and Bombardier, they all employ scores and scores of DERs to help them get their projects done. We have a sister company called Precision Cargo Conversions, and they actually own an STC to convert a 757 into a cargo plane, which there's been about 70 of them done. And then the latest project that they just got their flight testing done on is Airbus 321. And so that's what you can see there. You can see their project. They employ about, I think, maybe 30 or 40 structural engineers. And so what you're doing is you're taking this aircraft, again, it's all set up for passengers, and you're cutting into the side of the hull. So you've got to strengthen the structural members there, and then you've got to do all the electrical and all the structural, all the flight testing, because you're putting huge cargo doors on the side. Then when you have a track system designed for the cargo that's going to go inside, you've got a lot of structural work you have to do there, because you can't have things shifting around in flight. You have to be able to support the cargo that's in there without doing weird things to the hull. And so, this project here, we spent about 75 million designing and certifying our air tanker. This project here is about 110 million. And so, they're betting on the fleet of A321s, doing conversions on 20 to 25 of those a year for the next 20 years. So, big bets, big money are spent on projects like this, and you can't do any of it without a DER, without somebody with a good background there. So anyway, I thought that's something that, like I said, it's been fascinating for me to work with these folks, not just from an engineering standpoint, because really there's a lot of brilliant engineers out there, but the other thing they've got to do is they've got to understand the regulatory side of it. It's almost like building codes, right? What you have to do, what kind of design parameters, safety factors are designed into the aircraft, and it really is an important work. So when you're starting out, going to work, pay attention to that path, because I think it's a really interesting career path, and you make really good money because your skills are always in high demand. I don't know of any unemployed DERs out there, that's for sure. So anyway, that's a little bit about me. It's a little bit about my company. I talked about DERs. If I had to offer, nobody asked for it, but if I had to offer 3 pieces of advice, I would just give a few things, and these are things that have been that I've picked up along the way, or people have imparted this wisdom to me. To me, one of the most important things, and when I was in the Navy and I was graduating from nuclear power school, there was a speaker, and he came and he said this, and I always tried to live by it, and it served me well. But become an expert at something right away. And so it doesn't mean a know-it-all, right? But what it means is, hey, when you get to your company that you're going to go work for, it doesn't matter how small of a thing, right? Become an expert at it. It doesn't matter if it's how to work the copier machine, right? Because there are people that don't know how to do things on the copier machine. There are people that don't know how to use, SolidWorks or AutoCAD, or how to do certain things. So find where there's a need and become an expert at it, because then you'll become the go-to person for that, which facilitates relationships and communication with people. And then guess what? If you're an expert at one thing, it's pretty easy to become an expert at something else. And people will be more than willing to share information with you if you've got something to offer them. So that's something that you can hit the ground running with, like I said, your first day, at your new job. So that to me is one of the most important things you can do. The other things I would offer to engineers starting out is to gain project management skills. And when I think about project management, you have the whole time and money and all that thing. I look at it like, hey, I can do anything if I have enough time and enough money. How much money and how much time do I want to spend on it, right? Those are the decisions that we make here, every day. And so one of the frustrations that is rampant in aviation is and frustration with engineers is, yeah, we can do that. Well, all right. Well, how much time and money will it take? I don't know. And now there's some things you can't control, right? There's always uncertainty. You can't control how long it takes the FAA to sign off on things, right? But you can control how long it takes to analyze, something, this project that we're working on right now, where we're doing all these simulations to do the gear up drops. That's one of the things. These are seasoned engineers. They've been engineers for 50 years, and they have a hard time coming up with timelines and meeting those timelines. But they have a hard time meeting timelines because they overestimate their ability to get the work done and underestimate the complexity of it. And so my advice there, if you want to be taken seriously as an engineer, is take a class on project management. There, the Project Management Institute has classes online. Just get familiar with what's called critical path. What are the important things that are going to hold up this project? What are the things I have to prioritize? There's things that I could be working on right now that aren't constraints for any of the outputs, any of the commitments that I've made, but they still have to be done. But do I need to work on them in the middle of the afternoon? No, I can probably work on them at night or in the morning. And so you need to understand what are the things that are constraining your path to completion. I would argue, you probably have some indication of that already. You're trying to finish school. What are the classes that I absolutely have to have? Then what are the ones where I got a little bit of flexibility and control, right? That kind of thing. So gaining those project management skills will be useful to you as a young engineer, but also one day when you're a seasoned engineer and you're managing other engineers, right? Because now you're dealing with outputs from others, right? And helping them understand that, why X, Y, and Z need to be completed before A, B, and C or whatever. And then the other thing is, I would say, is learn to communicate with the business folks. So for me, being on both sides of the aisle there, the engineering side and the business side, one of the things that I used to do as a young engineer is, everything would become a science project, and I can understand why that's frustrating, to the numbers people, because now I'm kind of on that other side of the aisle, and I get frustrated when people come to me with a science project, and my question is, hey, why are we doing this? Why do we need? What answer are we trying to find? What problem are we trying to solve, right? And so the other thing, because I had an engineering background, is there were many instances that I can think of where I was able to influence decisions and, in fact, keep the business people from doing something stupid, getting rid of a product line or making a bad decision with, what we were doing with a customer's project, because I could explain the engineering side of it, and I could explain the trade-offs, and which were things that as a business person, you need people to explain those things to you. You need people to understand them at an in-depth level that can help you understand why you care. And so there's a lot to be gained there by being able to communicate with those business folks, because short of the sort of design decisions and the hardcore engineering decisions, they're making the business decisions, which is where they're going to spend money and what they're going to present to the customer, and what the next engineering project may be, based on the needs of customers and things like that. So learn to communicate with those folks, and you won't be sorry, because, like I said, you'll have some input in what happens, often at high levels in the company. But anyway, so those are three things there. I would say if somebody would have communicated those last couple of things to me, it would have helped me along in my career. And so I just wanted to give you guys those words of wisdom there. And again, good luck to everybody. That's my email address. Don't hesitate to get in contact with me if you want to know about anything. If you want to know about twin commanders, if you want to know about firefighting tankers, if you want to know about medevac aircraft, if you just want to ask my opinion on something, or if you want to talk about what's next for for you as a young engineer, or hear any more about my background and how NC State has been beneficial to me, it has benefited me. I would love to talk with any of you guys. So just reach out via email there. Yeah, so thanks, Josh, Brian, Carissa, for having me on. I really appreciate the opportunity to talk to your group. I guess now, if you guys have any questions, I'm I'm available. So just pipe up there. Let's hear it.
I've got one. Thanks for that presentation. My question would be, I definitely understand how valuable it is to like kind of learn if you're going to work in the aviation industry. I understand the value of learning the uh, FAA like regulations and how that might constrain like your design and your ideas. What's like the best way, like say I'm just starting out at my company, what's the best way that I can like get up to speed with that? Or is that something that would be like good to try to learn about before I go work for some company? What's your opinion on that?
Brian, that's a good question. And the answer, as the answer to many questions, is it depends, right? So you can go onto the FAA website and you can read all about designated engineering representatives. You can read all about certification process for an aircraft. You can read all about certification for different parts, but none of it really makes sense if you don't have context. Because again, I've been in that situation myself where I've gone in to try to understand something, and usually what's published out there in the FARs, which are the Federal Acquisition Regulations, and and Federal Aviation Regulations, is often too general. So when let's say you start at your first company, they're going to give you some engineering project. You're going to give you some projects to work on, and there's somebody there in charge of that interface, which is, hey, we need to run this data, and we need to figure out, what's the thickness of this stringer, that we need in this area, and so you're gonna figure that out or run those simulations or calculations, and then they're going to go and say, okay, they're going to take it to their internal DER, and he's going to say, what's your substantiation? And you show your calculations, and then they're going to sign off on it, or they're going to say, well, I need to know, something else. So that process, along the way, you're going to learn an awful lot. And then there are going to be times where you're going to have to open up the regulations. And when you get to that point, you're doing a little more than just engineering at that point. So I would say, that's something, be patient. I would say I wouldn't crack open the FARs yet, because it's just going to look like a foreign language to you. But you're going to learn along the way. And again, context is a powerful tool. When I was a student, I learned a lot as an engineer, but I learned a lot as an engineer because I had a background from being on a submarine where I was doing electronic technician work. So I had a lot of questions like, hey, why does this work this way? So it made the learning that I did there, in my electrical engineering curriculum that much more powerful. And then when I was a master's in business administration major, I had these questions, these business type questions that I came with because I was a working adult, right? And so having those questions that you need to have answered is a much more powerful tool for learning and B, remembering, because you can, if you pick up something that you looked at one of your textbooks from your first year, and you go and look at one of the assignments and some stuff you handed in, you might not remember anything about it. Like, oh, I can't believe I knew that, but it's because you never applied it after that, right? So when you go to work, you're going to learn that, hey, there's some things you learn that maybe you're not going to use again. There's a lot of things that you learn the theory of. Now you're going to learn a practical application of, and now you're going to have to learn. There's some other parts of that in the real world, back to the FAA and all this stuff that you're going to learn how to apply that. So sorry, I couldn't give you a better direction there, but that's what I think you're going to see. 5 years from now, text me and let me know if I'm right.
Okay, yeah, thanks. That makes a lot of sense that you put it that way. Yeah, that's great. Thanks.
Anybody else?
I have a question for you.
Yeah.
So when you're transitioning these passenger planes to whatever their future intended purpose is, what would you say the first step in the process is? It wouldn't be the structures analysis because you haven't done anything. Would it be flight stability and control to sort of see uh, what these potential changes would influence the aircraft and what's possible or not?
Good question, Josh. It all starts out in a conference room, and we sit and kick around. All right, what do we need to do, right? So for an air tanker, I'll use that as the most extreme example. Okay, what do we have to do with that aircraft that's different than what it does on a daily basis? Because when you think about an MD-87 and the passengers it's carrying, well, we're not exceeding the gross weight of the design of the aircraft, right? But we are concentrating it, right, in a smaller area. We are, doing different things with the angles and dangles that we do these drops at and that kind of stuff. So what you do is you start out with something that'll handle the load. In this case, hey, 27,000 gallons of retardant. So, okay, there's a lot of aircraft that can carry 27,000 gallons of retardant, but can it also carry 2.5 hours worth of fuel? Okay, it can carry 2.5 hours worth of fuel. Can it land loaded with retardant? So what's a max landing weight? Can it take off from a short field with a 27,000 pounds of retardant and a full load of fuel? So one of the things about our air tankers is we are the only tanker, and there's 5 companies out there that build these what's called large air tankers. We're the only tanker that can land fully loaded at all of the tanker bases that the Forest Service has, and they have over 100 tanker bases. And there are only 3 tanker bases where we have to take off with a load that's other than a full load. So last year they had us operating out of Silver City, New Mexico, which is a 5,500 foot strip. And we would actually take off in order to get to a full load of fuel. We would take off with 2 hours of fuel instead of 2.5 hours of fuel to not exceed any limits of the aircraft. But we were the only tanker company that could take off out of there with any retardant on board. And again, it's because of the engines, the design of the MD-87 is such that you can do that. So there's all these requirements of the mission that you look at first, and then you go, okay, the airplane can do it. Now, what's involved in modifying it? So I need to think about where am I going to put the tank? What kind of tank system? How am I going to what else do I need to carry on board? Do I have room to maneuver in the pits? The way retardant is deployed at Forest Service tanker bases is they have these pipelines for retardant, and you have pit areas. So can you maneuver in those pit areas? Is the aircraft nimble enough and sized right that you can get in and out of those areas? So there are a lot of things before we ever put together the first structural analysis that we talked about and looked at before we ever embarked on that project.
Awesome.
It's a lot simpler. It's a lot simpler on a med aircraft because you're not exceeding the weight. Hey, I need to put a patient and I need to put 3 passengers and a pilot or 2 pilots, and can the aircraft handle it? Yep. Okay. We'll modify the interior. So then there we look at things like, well, how big is the door? Because if I have a small door like what's on a Cessna Mustang, it's a lot tighter getting a stretcher in there than if I have something like what's on a PC-12 or a Lear 35. They have, those doors are 4 foot wide. Is that kind of what you're looking for there, Josh?
Oh, yeah. Sorry. Thank you.
Yeah, no problem.